Hi everyone, welcome to another exciting GeoPandas tutorial. So in this tutorial, I'm going to teach you how to use the information given in these kind of general websites to basically extract the names of different locations and how to use a geocoder in order to do a search and to retrieve information such as the exact addresses and the longitude and the latitude information, and to transform this kind of information into something that looks like this, where you can see that each of these locations actually have its full address, which has been retrieved fully automatically done using a Python code, which also has the longitude and the latitude information of that particular location. And finally, how to transform this information into an interactive HTML map that looks like this, which gives you the opportunity to sort of just hover around and not only zoom in, but to also display critical information that you would like to display in a map like this. So all of these will be actually taught and covered through this tutorial, and every step that you need to follow in order to achieve this will be explained in a very detailed manner. So the tutorial might be a bit long, but I definitely think that it's going to be worth it. So I encourage you to actually follow along and see whether you can replicate the exercises and to get the idea of how to use a geocoder using Python. So let's get started. So in order to do this, we are going to need a couple of libraries. Pandas and GeoPandas are two major libraries that you're going to need. I hope that if you have been following along my tutorials for some time, that you already have configured the Pandas and GeoPandas libraries. Now, in addition to those two, we also need to install two additional libraries. One of them is the GeoPy library. So you can simply install it by opening your Anaconda prompt over here. You can just go to your start menu and search for Anaconda prompt and run this as the administrator. And then you can just simply type pip install GeoPy. Now I have already installed GeoPy, so you can see that it says the requirement already satisfied, but if you haven't installed, you will see that it's getting installed quite quickly. And the second library that you would need is the Folium library. So you can similarly you can again type pip install Folium. Alright, just make sure that you install those two libraries, and now let's get started with the scripting. So let's get started by first saving our project. As you can see over here, I have already navigated to the folder which I'm going to work in. So if you want to do that, you can do that by clicking over here and browsing to the directory that you would want to work in. And after that, you can simply right click over here and create a new project. And I'm going to name this as... Alright, so let's get started by importing a couple of libraries that we are going to use for this tutorial. The first one is the Pandas library, and then the second one is the geocode module, which comes from the geopandas.tools. Now, as I explained in the beginning of this tutorial, I'm going to sort of drag some data from a Wikipedia page. I will put the link for this page as well down in the description below, so you guys can also just follow along with the tutorial. So as you can see over here, it's a Wikipedia page which sort of lists down the most visited places and monuments. So as I explained earlier, for this tutorial, I'll be dragging the data directly from this page. You can see the table over here, which consists of a list of most visited places and monuments, which has and in the table you can see the name, the country, and then visitors per year and the year reported. Probably I might neglect this column, but these are the three main important things that I'm going to sort of drag directly from this website. And let's see how we can do that. So I'm just going to go ahead and copy this address, and over here I'm going to create a new variable. And I'm reading it from this website. So let's run and see how it looks. Alright, now from here you can see that the code ran without any issue. So let's go to the variables explorer and see actually what happened. You can see that we sort of managed to save the information, but now it's in the type of a list, not really in a pandas data frame. So one easy way of sort of unpacking this data into a pandas data frame is just to iterate through this variable called data. So we can do that by simply using a for loop. And I'm going to say something like print. Now if you see in the variables explorer, you see that we created a new variable called monuments. And if I open that, you can see that we sort of successfully extracted the information from the website with some additional columns as well, which we probably might not need. So these things along the way, we have to sort of strip them out and then only extract the information that we are going to need. Now if I do a bit of a side-by-side comparison, you can see that we managed to extract the information such as the name, the country, flag, city, and the visitors per year, and also the year reported. Somehow there has been some issues with the column headings, but these things are actually to be expected because we are just abstracting the data from an external website. So we cannot expect it to be properly formatted in a way that we would want it. So that's actually a task that's going to be left for us to do. So it seems okay so far. So if I open this again, you can see that I would like to do a bit of refining when it comes to the headings of the columns. So one easy way to do that would be actually to save this into an external Excel file or maybe a CSV file and then read it back in. And then while you do that, you can actually just assign the names that you would like for the columns to have. So I'm just going to comment this out, and it's quite an easy and a straightforward command. So if you just simply give a name over here, it will get saved in the place where you actually keep your .py file. If not, if you really want to direct it to a separate folder, then in that case you have to actually give the full path. But if not, you can just give a random name. So we can run this command and see what happens. Now let's navigate back to the place where we saved the file and open it. And you can see actually this is how it looks. So it got saved without those long headings. So now I'm just going to read this back in as a pandas data frame. Monument equals to pd.read, and it's basically going to be the same name over here. So one flexibility with doing this is actually when we read in this information, we don't need to necessarily import all the columns back. So over here you can see that we have 1, 2, 3, 4, 5, 6 columns. So out of these 6 columns, I'm only actually going to import these 3 columns. But now you have to keep in mind that we are going to specify the index of the column. So if we start from 0, this would be the 0th column, the first column, second, third, and fourth column. So I'm just going to only import the second, third, and the fourth columns. You can actually also specify the name that you would like to have for these columns. So for example, I think you remember the first column actually consisted of the location, the name of the location. So we can actually put an argument called name or maybe name. And the second one was actually the location. So I can put another argument called location. And the third one was the number of visitors. So I'm going to make a heading called visitors. So let's run this one and see what happens. Now, if you go to these monuments, you can see that, well, it looks much prettier than the one before, right? But still there is an issue. Actually, I have one unwanted row over here, which I would like to get rid of. And you can see that that row is actually belonging to the index number 0. And altogether we have 39, including the 0 means we have 40 rows. You can also see that over here. So what this does is actually isolates the information which is located at the first row and the 40th row. So even though this is 39, just because it's index, which starts from 0, This is actually the 40th row. So you can isolate the information which corresponds to the first row up until the 40th row by passing an argument like this. And now if you run this command and if you open this, you can see that actually we got removed from that first empty row. So that's how you do that. And now you can see that it's actually looking much cleaner. So before we proceed on to the next part of the tutorial, let me take a moment to explain to you how actually this geocoding works. So basically what geocoding means is the process of converting the name or place of an address to a location on a map. And for this tutorial, I'm going to show you how to use GeoPandas to actually make use of these geocoding operations. So to give you a little bit of a demonstration, so let's say that we have a variable called info, and I'm going to make this variable equal to geocode. So for this tutorial, I can just say something like the Statue of Liberty. So now there are various types of providers. So some might actually need you a subscription, which involves something like you having to buy a subscription by paying some amount of money. But we don't have to necessarily go through that route. There's a geocoder called OpenStreetMap Nominatim. So today actually for this tutorial I'm going to use that, so we don't have to worry about getting any sort of a subscription or anything like that. So the provider's name I'm going to insert here as nominatim. So let's run this command and see what happens. A couple of seconds for it to process, and it saved some information into a variable called info. Now let's open this and see what happens. All right, now you can see that it gives us a geodata frame which has this geometry column, and it's a point, and also it actually returned us the address of the Statue of Liberty. So what happens is actually it's similar to what happens when we search things in Google Maps. You just basically search by a familiar name that you know of, and the geocoder is basically going to retrieve the information for you, such as the exact location of the thing that you searched. In this case, you can see that we managed to get the address and also the geometry, means the XY coordinates over here. So this is basically the concept that I'm going to use for this tutorial. Now you see that if I were to sort of gather information of famous places one by one, it's going to take a lot of time. So that is the reason why I created this data frame called monuments. Now you can see over here, we already have some column which contains the names of the places where people have visited the most all around the world. So instead of doing this one by one, I can actually run a for loop through each and every row over here, and we can actually use this geocoder to retrieve information such as the exact geographical location as well as the address. And after that, we can save those information into a new column, into two new columns over here. So that's basically the thing that I'm going to do today through this tutorial. So I'm just going to sort of automate the whole process, and I'm going to use this geocoder in order to accomplish that task. So let's see how we can do that. So first of all, as you might guess, I'm going to iterate through this monuments data frame. Every time when it jumps from one row to the other, and I'm going to search for the exact name and the location using the geocoder. All right, so this is the first line of the for loop, and then I'm going to write what sort of things that we need to accomplish during this iteration. You remember the first argument should be a familiar name of a place. So here I can specify it to be row, and the name of the column is name. So while it's iterating, it would be good for us to also see actually which exact value it's iterating over. So just going to add something like print row and the name. So it's basically going to print the name of the location which it's actually iterating over at that particular time. All right, so we'll run this and see what happens. Now you can see over actually it's iterating over the different locations. However, we ran into a problem. Now you can see that, so if it's a type error, cannot unpack non-iterable non-type objects. So this is actually a very common error which is associated with geocoding. Now, what I can think of immediately is that by looking at this particular name, my first guess is that the geocoder was not able to locate the details for this given name. For example, if I create a temporary variable called a, yeah, you can see that if I open this a variable, it was actually able to find, you can see that it's probably in Chinese, because this location called Forbidden City, it's located in China. So you can see that the address is in Chinese. But when I inspect this, you can see that the error occurred just after this location. So I'm just going to double check whether that was actually the real issue. So instead of using Forbidden City over here, all right, if I put the full name, which was actually included in that Wikipedia website, that's this name, which is located in Rome. Now let's see if this runs properly or not. All right, now you can see that that was the issue, because the geocoder cannot actually locate this locate the location of the location at the and the address of the Colosseum based on this provided name. Now, I mean, if you're a bit familiar about this location, which is the Colosseum located in Rome, you know that you definitely don't have to provide all these detailed information in order to locate that place. Let's see what happens if I just get rid of all of these and only leave Colosseum. In that time, we did not get any error. So if I open this a variable, yeah, now you can see that it actually managed to find the exact address of the Colosseum as well, and along with the geographical location. So these kind of issues actually are very common if you were to just totally rely on the geocoder, because sometimes it cannot actually detect the location based on the given name. So there are actually ways to sort of get around this. Now over here, if I open, I just have only about 39 entries. So in case if I have to make some manual changes, I think that's still acceptable because my data set is not that huge. But if you're dealing with maybe thousands and thousands of data where you need to sort of iterate through the information and to retrieve information from using a geocoder, then doing things manually will not actually be very effective. So in such a case, you can still actually rely on programming techniques to sort of get around these issues. Maybe you can just like clean this up a little bit, or maybe you can get rid of these characters which probably might be causing the geocoder to not recognize it. But for this tutorial, I'm sort of going to skip over all these type errors, which means whenever I have a type error, I will just ask the program to skip over it and then go for the next one, because the objective of this exercise is actually not to sort of correct all these small things. This is basically to demonstrate how we can use this geocoder to our advantage in order to retrieve things. So actually we can do that by using a simple exception handler. So for example, you can this try. So what basically this try means, you try something, but in case if you know that you're going to run into a certain type of error, for example, you know that whenever the geocoder cannot find your location, it's going to result in a type error. So I'm just going to say that just add an exception in case if you meet a type error. So we can say that except type error. Then you can provide something for the program to do in case if it meets such kind of a type error. So for example, if I meet such kind of a type error, I can just print something like It's not found. One, so that we are aware of the locations where the geocoder cannot help us to retrieve information. All right, at the same time, I also actually would like to create two new columns, actually three new columns. You can see that if I open this information over here, you see that this information, which is sort of generated using our geocoder, it generates two outputs. The first one is the address and the second one is the geometry. So I'm actually interested in creating a new column in my main data frame, and in a new column I would like to actually input the address which the program retrieves for me, and in the second and the third column and in the next two columns I would like to sort of extract the XY coordinates from the geometry column. So in order to do that, we can do something like this. Now this is how you create a new column in a data frame. Over here we put the location, index, and then the new column that you would like to have. And this one is basically going to be equal to, and if I open this info, you see that always it creates two columns. The first column is, the first column is geometry, the second column is address. So I'm just going to sort of use this same lowercase address over here because I want to get the address from here. Still, you see that this column is belonging to the entry, which is the address which I want, is located at the 0th place in terms of its index, in terms of its row index. So that's why I have to also specify which location, what is the index of the row over here. So when I do this, it sort of retrieves the information from here and then it's copying it to the corresponding new column every time when it loops over the information row by row. All right, so similarly, I also would like to make two new columns. So the second column, I would like to name it as longitude, the lon. This one we have to get from the geometry. Still geometry, location 0, but then when you need to extract the x coordinate, you can simply put dot x. So basically what happens is that whenever you specify x, this value will be retrieved, and when you specify y, this value will be retrieved. These values are in decimal degrees. All right, now we can run the code and see what happens. So over here you can see that now it's iterating through different locations. All right, now you can see that we successfully skipped over the place where we do not have the information for. And you see over here there's another location where we do not have the information. All right, it seems like the process is done already. It took a while, but not so much, just even under a minute, I guess. Now we can open these monuments and see how it looks. All right, now it looks perfectly as I expected it to be. You can see that each of the addresses got sort of recorded along with the names and the longitude and the latitude locations as well. Now you see that there are certain locations where the geocoder cannot help us to find. So I'm just going to ignore those. Means I'm just going to sort of get rid of these rows where we don't have the information for, because it's pointless keeping them. So we can do that simply by doing a drop NA operation. drop NA. So that one is pretty straightforward. Specify the name of the file. Alright, now let's run this command and see what happens again. Yeah, actually, since we are running over the whole script, you can see that it's actually taking that same amount of time in order to retrieve the information using the geocoder. But that's fine because we are doing this just for the demonstration purposes. So it's going to take a while. Alright, now it's done. Now if I just navigate back to the place where I keep my files, you can see that we have this Excel file called most visited monuments, and you can see very nicely formatted Excel table which has all the information that we probably might need in terms of the addresses and the geographical locations of the most visited monuments all throughout the world. Alright, so in the second part, in the second part of the tutorial, I'm going to show you how to actually plot this information into a Folium map. It's sort of an interactive HTML map, so you can sort of transfer all this information that you retrieved into that map based on this latitude and longitude information that you basically extracted using the geocoder. And now I'm going to use a Folium map in order to transfer this information into a bit of an interactive map. So for that, I'll actually create a new script. Actually, you can even, if you would like to do it in the same script, actually you still can do it, but just to make things not messy for the viewers, I'll actually create a new Python module. And I'll name this one as geocoding display data. So for this, I'm just going to import a library called Folium. I'm going to read back this Excel file which we saved, which consists of the information of the most visited monuments. Alright, now I'm going to read this Excel file back into Python, and I'm going to assign that into a variable called dataset. Alright, now let's run this one. Alright, now you can see that we imported the libraries without any issue. And now if I go to the variable explorer and if I just open this dataset, you can see that well, now just to be clear, I can clear all the variables so that we won't confuse it from the variables from the previous part 1 tutorial. So I'll run this one again. And now we have this variable called dataset, which we read directly from that Excel file. And I'm also going to actually get rid of this column. And over here, we can specify the name of the column that we need to remove. All right, now we can run this command. And now if I open over here, you can see that now it looks quite clean. All right, now I can create a new variable called m, and I'll make it equal to folium.map. this is how to just basically change the appearance of your map. And now I'm going to actually run through this information using a for loop, and at each iteration I'm going to retrieve information and then sort of throw that information into this Folium map that we created. So let's see how do we do that. First I will take the latitude and put a comma. Going to take these two values and then use that as xy arguments over here, the latitude and the longitude information over here for each iteration. Specify the pop-up name as row and the name, and all of these things I'm going to add them to this m. I would actually like to save this m into an HTML file, so we can do that by specifying m.save. We can give the argument as monuments around the world. Alright, now let's run this command and see what happens. I can navigate back to the place where I saved the files. Here you can see that we have a new HTML file called monuments around the world. I can open this and you can see that it's actually an HTML file, sort of an interactive map weaver. Now these are the different locations actually we retrieve the information for. So for example, if I basically just zoom in into a place where we know, you can see that there's one monument in London over here, and I also can actually click on this one. That's the pop-up that we mentioned over here. So if I specify the name to be the pop-up value, it will actually give me the name of that particular location. So if I zoom in a bit over here, this is supposed to be the Tower of London. So let's see if that's accurate or not. Yeah, you can see that actually it's pretty accurate. So similarly, I can actually just check that maybe something from Paris. So this is supposed to be the Eiffel Tower. So if I zoom in over here, and it's actually the location of the Eiffel Tower. But keep in mind that sometimes when we retrieve information using a geocoder, things might not always be accurate, because it's basically relying on the string that you're providing it to sort of do its search. So sometimes you might find overlapping information where the name that you give might be actually common to two different places, rather than it being like very unique to a certain place. So I think this is the Forbidden City, if I'm not mistaken. Yes. And if you even want to display more information when you actually click on top of this one, for example, you can do a bit of a change over here. So the pop-up, you can specify something like name plus. So this is basically a special argument that you can use to jump a row. That's this information. So you can actually run this command again, and you can open that HTML file again. And now if you zoom in a little bit, You can see that this information gives you the name, which is in this case it's the Edinburgh Castle, and you can also display the number of visitors per each year, as I remember. I can also actually make a quick check. This is supposed to be the Statue of Liberty, and this is the number of visitors you get. So basically that concludes the tutorial which I wanted to do today. I hope you learned something very valuable, and if you did, please comment it down below. And if you do have any questions, do not hesitate to raise your questions in the comment section as well, and I would be very happy to answer them. So thanks everyone for watching this tutorial, and I'll see you in the next one.